Before we begin talking about the 4 pathways of the sympathetic nervous system, I would like to review a little bit of information. It's important to review this information because we're going to be building on it throughout this video. First off, let's talk about how the nervous system always has sensory information coming in and motor information coming out. Of the sensory division of the nervous system, we have 2 branches, the visceral sensory and the somatic sensory. Visceral sensory deals with stimuli from the visceral organs or the internal organs. The somatic sensory division deals with information from the somatic senses, such as touch, vibration, pressure, and temperature. Over here in the motor division, we also have 2 branches, the autonomic motor and the somatic motor. Autonomic motor is motor output to involuntary responses, such as cardiac muscle, smooth muscle, and glands. Somatic motor is motor output to the skeletal muscle, which is voluntary. The somatic sensory division communicates with the somatic motor division, and the visceral sensory division communicates with the autonomic motor division. Furthermore, the autonomic motor division has 2 branches, the sympathetic and the parasympathetic. The sympathetic is your fight or flight response, or, in other words, the nervous system that's activated during emergency situations. The parasympathetic division is your rest and digest, or the nervous system that's activated during non-emergency situations. We're going to be focusing on the sympathetic nervous system. The sympathetic nervous system has 4 possible pathways, and that's what we're going to be talking about in detail. In the motor nervous system, we have neurons that originate in the CNS and then travel away into the PNS and go to their target organ. In the somatic motor division, we have 1 neuron. It starts in the CNS, such as the brain or the spinal cord, and leaves the CNS, goes through the peripheral nervous system, the PNS, and goes to its target organ. In the case of somatic motor, the target organ would be skeletal muscle. In both the parasympathetic and sympathetic, we have 2 neuron chains. What makes them different is in the parasympathetic, we have a long first neuron. The first neuron is called the presynaptic neuron, and a short postsynaptic neuron. And that postsynaptic neuron goes to the target organ, such as glands, cardiac muscle, or smooth muscle. In sympathetic nervous system, we have the inverse. We have a short presynaptic neuron and a long postsynaptic neuron. But once again, that postsynaptic neuron is going to a target organ, either a gland, cardiac muscle, or a smooth muscle, all of which are involuntary. Now let's talk a little bit about the structures we need to know for the 4 sympathetic pathways. Let's start at the spinal cord with the horns. Posterior horn, lateral horn, anterior horn. After the horns, we have the roots. Posterior root, anterior root. Don't forget that the posterior root only has sensory neurons, and the anterior root only has motor neurons. When the 2 roots come together, they form a spinal nerve. The spinal nerve has a mix of sensory neurons and motor neurons. The spinal nerve splits into 2 rami, the posterior rami and the anterior rami. The posterior rami is much smaller because it's only innervating the muscles and skin of the back, whereas the anterior rami is much larger because it innervates everything anterior to the spinal cord. Next, let's talk a little bit about ganglia. Ganglia are just clusters of cell bodies. And like we talked about, the sympathetic and parasympathetic division both have 2 neuron chains. So where the presynaptic neuron synapses with the postsynaptic neuron, we end up getting a cluster of cell bodies, or a ganglion. And just note that the presynaptic neurons are myelinated, and myelin is white, and the postsynaptic neurons are unmyelinated, and unmyelinated neurons appear gray. And that's going to be important here in just a couple seconds. So, like I said, ganglion are clusters of cell bodies. We need to know 3 different sets of ganglion. First, we have the posterior root ganglion, or the dorsal root ganglion, here and here and here, and that's where the cell bodies of sensory neurons are located. Next, we have the sympathetic trunk ganglion, which would be these guys. The sympathetic trunk ganglion are connected to each other by the sympathetic trunk. The sympathetic trunk ganglion are paired and they lie just lateral to the spinal cord. Third and last, we need to know about the prevertebral ganglion. Prevertebral ganglion lie just anterior to the spinal cord, which is why they're called prevertebral, in front of the vertebrae, prevertebral ganglion, and they're unpaired. The prevertebral ganglion are connected to the sympathetic trunk ganglion via splanchnic nerves. And the last thing we need to talk about are these right here, the white rami communicant and the gray rami communicant. And these are the entrance and exit ramps to the sympathetic trunk. The white rami communicant is always the entrance, and the gray rami communicant is always the exit. And the reason why the white rami communicant appears white is because those presynaptic neurons, which are the ones going into the trunk before the synapse, are myelinated, which appears white. And the postsynaptic neurons are unmyelinated, which appears gray. So the gray rami communicant is the exit, and the white rami communicant is the entrance. Now we can finally start talking about the 4 pathways of the sympathetic autonomic nervous system. What we're really interested in is what are the identifying features of each pathway, or what makes each one different or unique. So for the spinal nerve pathway, we're going to have a presynaptic neuron that starts in the lateral horn of vertebrae T1 through L2. From there, it's going to leave the spinal cord via the anterior root. And it's leaving via the anterior root because it's a motor neuron. If it was a sensory neuron, it would be going through the posterior root, but it's motor neuron, so it's leaving through the anterior root. After the root, it joins the spinal nerve, and then it takes the white rami communicant into the sympathetic trunk. Once it's in the sympathetic trunk, it can either travel up, down, or remain at the same level. So for this case, we'll just have it stay at the same level. So it's going to synapse in the sympathetic trunk with a postganglionic neuron. And then the postganglionic neuron is going to leave the sympathetic trunk through the gray rami communicant, rejoin the spinal nerve, and go to the target organ, whatever the target organ may be. So like I said, we're interested in what makes each pathway unique. And the 2 unique factors of the spinal nerve pathway is that once the postsynaptic neuron leaves, it rejoins the spinal nerve, which is why it's called the spinal nerve pathway. It's also the only pathway that exits via the gray rami communicant. Now we're going to talk about the splanchnic nerve pathway. The splanchnic nerve pathway has a preganglionic neuron that starts in the lateral horn of T1 through L2, which is the same as the last pathway. From there, it leaves via the anterior root, just like the last pathway, enters the sympathetic trunk via the white rami communicant, just like the last time. And once it's in the sympathetic trunk, it can travel up, down, or stay at the same level. So since we had the last one stay at the same level, let's have this one go down a level. So it travels through the sympathetic trunk to the next sympathetic ganglion, or several sympathetic ganglions. But basically it travels through the sympathetic trunk. But here it doesn't synapse in the sympathetic trunk like the spinal nerve pathway does. That presynaptic neuron continues and it leaves the sympathetic trunk through a splanchnic nerve and goes to a prevertebral ganglion, which is where it synapses. So the postsynaptic neuron starts in the prevertebral ganglion and it travels to a target organ. In the case of splanchnic nerve pathway, the target organ is always digestive organs, because the role of the splanchnic nerve pathway is to shut down digestion. Because if we're in a sympathetic situation, an emergency situation, we want to divert blood flow away from the digestive tract and use it elsewhere. So the splanchnic nerve pathway is going to inhibit digestion. And remember that we want to look for identifying features or things that are different about this pathway than any other pathway. So for the splanchnic nerve pathway, it's unique because it's the only one that synapses in the prevertebral ganglion. As you'll see in a second, the other pathways go through the prevertebral ganglion, but they don't synapse there. And the other special unique feature is that it inhibits digestion. Now we're into the third pathway, or the postganglionic nerve pathway. The postganglionic nerve pathway is going to have a presynaptic neuron or a preganglionic neuron, whatever you want to call it, that originates in the lateral horn of T1 through L2, just like the others, goes through the anterior root, through the white rami communicant, into the sympathetic trunk, just like the others did. And once it's in the sympathetic trunk, it can either travel up, down, or remain at the same level. So since the last one traveled, we'll have this one remain at the same level. So in the postganglionic nerve pathway, we have a synapse in the sympathetic trunk itself. And after the synapse, we have a postsynaptic neuron or a postganglionic neuron. But rather than leaving through the gray rami communicant like the spinal nerve pathway did, it's going to leave through the splanchnic nerve, kind of similar to the splanchnic pathway. So the postganglionic neuron leaves via the splanchnic nerve, but before it ever gets to the prevertebral ganglion, it's going to leave and go towards its target organ. So I like to think of the postganglionic nerve pathway as a hybrid of the spinal nerve pathway and the splanchnic nerve pathway. It's similar to the spinal nerve pathway because it synapses in the sympathetic trunk, just like the spinal nerve pathway did. But in the spinal nerve pathway, our postganglionic neuron left via the gray rami communicant and rejoined the spinal nerve, whereas here, the postganglionic neuron leaves via the splanchnic nerve, just like the splanchnic pathway. So that's why it's kind of a mix of both. Now we're finally on to the final sympathetic nervous system pathway. The fourth pathway is called the adrenal medulla pathway. And the adrenal medulla pathway is pretty unique compared to the others, and you'll see why in just a minute. So for the adrenal medulla pathway, we're going to start with the neuron originating in the lateral horn of T1 through L2, just like everything else. Once again, it's going to go through the anterior root, through the white rami communicant, into the sympathetic trunk. And once it's in the sympathetic trunk, it can travel up, down, or stay the same. For this one, we'll have it travel down to this next sympathetic trunk ganglion. From the sympathetic trunk ganglion, it's going to leave through the splanchnic nerve. Then it's going to pass through the prevertebral ganglion, but it's not going to synapse there. It's going to leave the prevertebral ganglion and go to the target organ. And for the adrenal medulla pathway, the target organ is the adrena medulla. The adrenal medulla refers to the adrenal glands. The adrenal glands are paired glands that sit on top of the kidneys. The adrenal glands have two portions: the outer portion, which is called the cortex, and the inner portion, which is called the medulla. So for the adrenal medulla pathway, we have a neuron that goes from the CNS to the inner region of the adrenal gland. As you can see, the unique identifying characteristic of the adrenal medulla pathway is that there's only one neuron. The other three sympathetic nervous system pathways that we've talked about all had two neurons, but the adrenal medulla pathway only has one. When the adrenal medulla pathway stimulates the adrenal gland, it causes the release of norepinephrine and epinephrine. When these chemicals go through the bloodstream, it's called an adrenaline rush. So now we've covered the four pathways of the sympathetic autonomic nervous system. Make sure to review the material and be able to recognize each pathway based on their identifying characteristics.